What we have looked at recently are pulleys, and what you see here is a couple of pulleys here. I have a mass hanging off here. This is 200, 400, 450 grams hanging on left. It's attached to a mass over here. That's just there to keep it from, so it doesn't fall. I want to keep everything in frame here. And what we want to do is to look at what's going to happen. All right. Now, obviously, this is 450 grams. This is 150 grams. This guy here is 150 gram holder, 250 gram holder. So when I let this go, of course, the heavy one is going to fall down, and the lighter one will. Oops. Let's see. I guess this is infected by the coronavirus. It's not working correctly. Get the virus off. Try it again. When I let go, obviously the heavy one is going to go down and pick up the lighter one. What? Anyway, this is obviously what's supposed to happen. And what we are going to do is to try to figure out why using the tools that you have already learned. It's not any more complicated than you have already seen. We just want to wrap our heads around this to see exactly how to analyze this. What you see here is 2 pulleys on the bottom. At the top, you have 3 pulleys. This is called a block and tackle. Okay. This is a single string. The single string down here at the bottom. Right. This single string here goes up around the top pulley, down along the bottom pulleys, back up, back down, back up, and back down. Okay, and what happens is we need to, in order to analyze this, what we want to do is to go back to our free body diagrams. Now you guys have, that's part of the procedure that I have given you. In a situation like this, it's actually quite useful. Now the idea behind a free body diagram is, let me go back to here and just look at this one. The free body diagram. The free body diagram is you draw a box, and inside that box you place the mass. So this is our free body diagram. Okay, let me raise it up a little bit to make sure that you can see it. You want to pretend you don't see anything inside that box, right? We know that there's 150 grams there, so gravity is acting down on this black box. And what do we have? We have this one string up. So what do we have? We have gravity pulling down, and we have this string pulling up. Okay, so far so good. That one's easy. We want to do the same thing. This will be our free body diagram. And what you do is you draw a box. Inside the box, you place the mass. Now, there's the mass that you see, okay? Maybe I need a little bit longer paper, so I'll magically make the paper twice as long, right? Inside the box, you have the masses. So we have gravity pulling down. What do we have pulling up? What do you see pulling up? You have how many strings? Remember, this is a single string, but as far as what's cutting through the boundary of the box, and that's the crucial thing. The box is this imaginary thing. We don't know what's inside the box. Unless I pull the box away, we'd have no idea what's inside. We don't need to know what's inside other than the mass. The boundary of the box is there simply to help us identify the forces that are acting from outside the box. We don't care about the forces acting inside the box because they would be action-reaction pairs, and they would cancel in pairs. The only forces that we care about are the forces that act through the boundary of the box. Gravity's acting down, see? Gravity's acting down, and then we have 1, 2, 3, 4, 5 strings. It's the same string, but that one string is pulling up 5 separate times. Okay? As a result, you can pick up a heavier object by using a smaller mass. All right, you're not gaining anything. You're not getting something for nothing there. If you one key to this, when we get to energy, which we haven't gotten to yet, this guy will move farther than this guy. Okay, as I move down, let's say I go from here to here. Notice that this mass has moved 5 times farther than this mass has. Okay? If I start from here, I started from here and I go down, right? This guy has gone down 5 times farther than this guy has. So the work done, which we'll see later on, the work done is going to be the force times the distance. We have a larger force acting over a smaller distance, we have a smaller force acting over a larger distance, okay? And that's what ultimately allows us to pick up heavier objects. You see that, you know, especially here in DC, you walk around town, you'll see these cranes everywhere putting up buildings. Look at the edge of the crane. You will see a block and tackle taking place, okay? The very top where the mass is being pulled up, you follow it all the way to the top, generally you'll see something like this where you have 3, 4, 5 pulleys all pulling on the mass that's being lifted. And the mass that's the mass that's doing the pulling is, in this case, 5 times. This mass, this force, is the same force that's in here. This force, this tension here is the same tension as here, is the same tension as here, is the same tension as there, is the same tension as there, is the same tension as there. So ultimately, the force pulling on this is 5 times the force that's pulling down on the tension in the rope. Physics is fun.